pick the left side to work with. Common denominator? Do you agree that that would be a good step to take? We could maybe try to simplify that a little bit if we wanted to first, but how could you rewrite cotangent? 1 over tangent, or in terms of sines and cosines, cosine over sine, which means like it wouldn't cancel out the cosine, so that's what I'm just going to leave it for now. But what I think is if I see subtraction here, right? I can get a common denominator because I need this to just equal cosecant over here. So getting that common denominator is definitely going to happen at some point. Alright, so this side's not going to change. Cosine theta, cotangent theta, all over 1 minus 9. And then I have to multiply up here 1 minus sine theta. I've done this already. Remember, if you're subtracting that whole thing, so that's going to become minus 1 plus sine theta. One that's not so obvious what to do next, right? I definitely don't think anything is going to cancel out. I can't factor anything out of the top right now. So the only thing that I see is what I didn't do up here. Could I rewrite this as cosine over sine? Can I do that above this just to save a little bit of room? So if I put cosine times cosine over sine, that would just give me cosine squared over sine. I got the cancel. And then I have minus 1. And then I have plus sine theta all over 1 minus sine theta. Better? What if you just had the numerator there? Forget about the denominator. If I gave you a problem with just this numerator, do you have any suggestion of what you would say, what we could try to do to simplify it? Fraction. I'm trying to get it to turn into one thing on this side. Yeah, I think we need to do another common denominator on the top there. Which is not an ugly common denominator. We just need to make this over sine, and we need to make this over sine. Right? So don't forget about your bottom here. We have this 1 minus sine theta. But now I'm going to make all of this the denominator of sine. So this one's not changing. It's going to just be cosine squared. But this is just 1 over 1, so I have to multiply by sine over sine. So now that's just going to be minus 9. Plus, which is also just sine over 1, and I need a sine on the bottom, so I have to multiply a sine on the top. So that would be sine. Sometimes it feels like things get worse before they get better, but if you see things that are subtracted that you can make into fractions and get a common denominator, it's a good step to take most of the time. Because hopefully you're going to see some things going together now. Like on the very top of that, anything you can put together that we said a couple times before? Do I have cosine squared plus sine squared? I would have never gotten that if I didn't get a common denominator. So it's why common denominators are such a reoccurring theme when we do this. So that just equals 1. So now I have 1 minus sine of theta over sine of theta. Let's do it over again. Over 1 minus sine. And again, that's the hard part. The easy part is sitting in class. I can nudge you towards the right answer, or I can just say you think about it. The hard part on your homework, and on your quiz, on your test, is I can't nudge you, right? You have to think of the strategy on your own of what to do. But it got kind of ugly for a minute. So now we should be in the home stretch here. Right? This would be like 1 minus sine of 1, right? So let's split that up and multiply by the reciprocal. Again, I feel like you have to have a really strong background, a really strong understanding in fractions to be successful with these. That when we divide by fractions, that's the same as multiplying by the reciprocal. And now I can cross it out. Make 1 minus sine of theta. Multiply it and then tell them it equals the right thing. The reason I didn't print your notes out because I just keep mixing the page, and then if I print it on, I just have this 1 over sine. So secant theta underneath. There's this math process there that says that you're going to persevere through problem solving. I don't feel like there's any better example of that than these problems, because it's so easy to try one thing and then say, well, I don't know what else to do, and give up, as opposed to saying, well, what if I wrote it like this, or what if I tried this? And again, there's been many a time that I try something and I cross it out, right? The Max 137 ones, the ones in their book, they're really tough. There was one that I redid this year just to make sure I felt good about them, that I cropped out and felt good about that I did it. And then there was one on the quiz from Ivy Tech that it was really tough, and I thought I was doing it wrong, and I cropped it out, and I ended up I was doing it right, and I didn't the problem is so again, that's my suggestion to you, is when you think your stuff, like, your job is to say, what else could I do? The problem is, maybe you're stuck because you made a mistake. You didn't do a negative sign. You make a negative part that I got. Alright, let's try to. This one looks crazy, but I think it's easier. X's and Y's here, so you have to kind of be. I think this might be my other example. I'm not making it. For the second problem. Yeah. I got to a certain point, and then I was like, wow. I feel like I wrote wow next to that. Do you think it really matters which side we choose? We're either going to change a bunch of tangents into cotangents, or we're going to change a bunch of cotangents into tangents. Be really careful here, because there's an X and Y. It's easy to interchange those. So if it doesn't matter which side to work with, I always work with this side. If I want to take tangents and make them into cotangents, what do you think is a good first step here? Can I write every one of those tangents in terms of cotangent? So tangent of x, I could write as 1 over cotangent of x. And tangent of y, I could write as 1 over cotangent of y. Which means I'm going to make this look kind of ugly, right? But I need them to be cotangents. So I'm going to write this as 1 over cotangent of x plus 1 over cotangent of y over 1 minus This is multiplication, so we can make it all 1, or we can make it 2 separate ones. Doesn't matter to me. We're going to have a 1 on top, and then we could say this is cotangent x times cotangent y, just because 1 over cotangent x times 1 over cotangent y, we can put that together. So I'm going to do it's close, right? But you can't just like make those things disappear. Next, the theme of the day. Common denominator. We need a common denominator in the numerator. We need a common denominator in the denominator. Right? Because we cannot cancel stuff out. It's not really fun to invert and multiply if you have addition and subtraction, because there's lots of things that can go wrong there. So if you have addition and subtraction of fractions in a fraction, you should always get a common denominator first. So on the top here, right, my common denominator is just going to be cotangent x, cotangent y. So this side needs a cotangent y. This side needs a cotangent x. On the bottom, right, that's just 1 over 1. So I just need this to multiply over there, right? So it's also going to be over cotangent x, cotangent y. And that's going to be cotangent x, cotangent y. Minus this side doesn't need anything, right? So that's just going to be minus 1. Pretty much there. Almost one more step. It's up to you how you want to do this. You definitely could multiply by the reciprocal. We also could use what we've learned with trig as we've gone along the way, right? When I take tangents and I get like 1/2 divided by square root of 3 over 2, right? We kind of just always cross those 2's out. It's not a magic trick. It's because when you invert and multiply, if the denominators are the same, like it is going to cancel out. And if you recognize that and you don't want to rewrite it and cross it out, I'm totally okay with you marking it out. If you're not sure, multiply by the reciprocal and you'll see that this side will flip up and then those denominators will cancel out every time. But I like this idea because can't do that with addition and subtraction, but now that we have a common denominator, we can. And cotangent y plus cotangent x is the same as cotangent x plus cotangent y. Sometimes I'm going to rewrite it anyway. It looked ugly to start with, but it was less steps than nothing in the end. Questions about that? Okay. I think maybe 5-2 day 2, and this is on the paper. I'm going to get to you in a minute. There's only, what, 7 problems there? Or maybe a little bit harder problems. Also, one of the problems, the way that I did it, is I ended up having to factor a sum or difference of cubes. Remember that? Sum or difference of cubes? That was a while ago. So anyway, that's why I put this on here. I was like, hey, maybe you need to remember how to factor the sum and difference of cubes. Maybe there's a better way to do it than what I did. But, so like, you have like sine cubed minus cosine cubed. Then you could factor that into sine minus cosine, sine squared, plus sine times cosine, plus cosine squared. Oh, that's an element too. You can also review that, I think, as well. using this time sheet that we are not going to do a test in the fourth grade, right? Means that you can get it kind of I also just put some very odd math handwriting on it that really has nothing to do with it. My favorite math joke ever is pretty odd. That's proof by that. The plan is tomorrow that we're going to have a worksheet, so that means we'll have time to go over some questions tomorrow, where you have the worksheet, and then you'll have the worksheet as kind of a little review. When we take this quiz on Wednesday, it'll probably be a combination of 5 and 5 means there'll be some that are just simplify, like the worksheet I have to get back to you that you did on Friday. There'll be some solving equations, and then there'll be some verifying anything. Not a long quiz, but just to kind of see where we are on this and how we do. So I'm going to pass back that worksheet on Friday. My advice is kind of look over it. I didn't grade all of them, but I check mark the ones I grade so that you know what I graded, and that'll be a review thing we'll talk about tomorrow that you'll want to review that as well before the quiz on Wednesday. So as I'm